Okay, here is warm-up 10PT. So first we're going to solve for r. I've got a circle and then I've got this triangle here. And this appears to be a segment that's tangent to the circle. So when you've got a segment that appears tangent, you can assume it's tangent unless they ask you, is that tangent or not? That's the only exception. But here it looks like a tangent line, which means it's going to be perpendicular to the radius that it connects to. So that means I've got myself a right angle right there, okay? And now that opens a door for me because I've got a right triangle and I can use the Pythagorean theorem in order to solve for r. So let's go ahead and do that. So the Pythagorean theorem is going to look like this, right? My legs are r and 21. The hypotenuse is going to be both of these segments added together. So hypotenuse is going to be r plus 9, right? So I want to put that in parentheses like that. I'm going to square that whole binomial, okay? And this is not just going to be r squared plus 81 because I have to think of this as r plus 9 times itself, which means I'm going to have to FOIL this, okay? I can put in 21 squared, which is 441. Okay, and then let's go ahead and FOIL here. So first, outer, inner, last, to multiply these together first. In front of their parentheses, r times r is r squared. Outer, those are the pieces on the outside, r times 9. Inner, 9 times r is 9r. And last, 9 times 9 is 81. Okay, and I can combine those into 18r over there. Okay, so I got it down to this. So I still need to solve for r. So I want to start combining like terms. And let's get these r squared terms together first. So, hey, I want to move my r squareds to the left, so let's subtract. And hey, look at that. Actually, when we subtract from r squared from both sides, something really nice happens. No more r squareds. So now it's not looking so bad. I just have to isolate the r. So I'm going to subtract 81 from both sides first. That'll give me 360 over here. And then I'll divide by 18. And then r is going to come out to exactly 20. So my radius is 20. Okay. All right. The biggest mistake I see on these is that people do the squaring incorrectly. You got to remember to FOIL that out. Okay, next up, I've got a quadrilateral that's inscribed in a circle. And when that happens, every time the angles that are across from each other, opposite each other, are going to be supplementary. So these two will add up to 180. These two will add up to 180. So I can write 5x plus 110 equals 180 degrees. And so let's see, just subtract 110. So 5x is going to equal 70 degrees, and then divide by 5. And x is going to come out to 14. And I actually don't need to put the degree symbol in my final answer because it's in the picture, right? It's just what I'm plugging in for x there. So I'm just going to say x equals 14 there, okay? And likewise, I can say 2y plus 104 is going to equal 180. Subtract 104. 2y then will equal 76, and divide by 2. Oh, just about off screen. Let me zoom out a little. Okay, there we go. All right. So next up, I've got a circle, and then I've got these two tangent lines that are going to intersect outside the circle. Okay, and when that happens, I've got two arcs. So this is one of my arcs where the 138 goes from point L to point N. But I'm also going to need this arc. I call this one the small one because it's going to be smaller than this arc, right? So this is my small arc's 138. I still need to find my big arc, And I can do that because the whole circle is 360 degrees, right? So if I take the small arc plus the big one, it will equal 360. So that means the whole circle minus the 138 is going to equal the big arc, right? So 360 degrees is the whole circle. Subtract 138 from that, and I'm going to get 222 degrees. So that bigger arc is 222. Okay. Now I'm going to need that because the formula here, when I have two, there's always a relationship when two tangents meet outside a circle like this. The angle is going to be equal to 1/2 of the big arc minus the small arc. Okay. So here my angle, I mean the angle on the outside, that's the x in this case, is going to equal 1/2. The big arc would be 222, and the small arc is 138 degrees. Okay? If you subtract the wrong way, then you'll get a negative number, and you'll know you're not going to have a negative measure for an angle. Okay? All right, so then 222 minus 138 comes out to 84. So I've got 1/2 of 84 degrees. That's just like dividing by 2, right? Multiplying by 1/2, same as dividing by 2. So x is going to equal 42, and I'm actually not going to put the degree in my final answer because it's already in the diagram there. It's just a number I'm plugging in. But yeah, that measure of that angle would be 42 degrees. Okay. All right, last one. We're going to solve for x here. All right, I've got these are two chords that meet inside a circle. And when that happens, there's also a relationship between the angles and the arcs that are intercepted. So this angle intercepts this arc. And if you think about it, we've got vertical angles here. So if this one is x, this one is going to be x as well. So x also intercepts this arc. Okay? And here the relationship, when we're dealing with an angle inside the circle like this as opposed to outside, we've got a very similar formula here. But the angle is going to be equal to the average of the two arcs. So the way I would average the two arcs is I'd add them together, and divide by 2. So it doesn't really matter which one's the bigger or the smaller one because we're just adding them anyways. So dividing by 2 is the same as multiplying by 1/2, right? So I just wrote it this way to show you it's almost the same formula. It's just we're adding the two arcs instead of subtracting them. Okay, so here my angle is x, and then I've got 53 and 41 for my arcs. So I'll do the addition first. That gives me 94, and then 1/2 of 94 is 47. And there is my answer. And that's the end of the warm-up, and I'll see you next time. Take care.